We are Audrey, Daniel, Phoebe, and Stephen, and we are the system team working on the Reconfigurable seating system for transit vehicles project. Before introducing our design, we would like to thank our sponsors, Joseph Mello and Rich Hollingsworth, our advisors, Sarah Harding, and Jim Dunning and Andrew Brown for helping us through the grant proposal process.
Traditional transit vans come in set configurations, meaning the seat placement is rigid. This lowers the efficiency of these vehicles to transport luggage and passengers, since these vans may not have enough or too much space for things like baggage, bikes, and wheelchairs. Having rigid configurations also means that transit companies are required to buy multiple layouts for vans in order to meet customer needs. For example, Star Trans offers 3 different configurations of transit vans for purchase. Our solution to this is a configurable seating system, which was pioneered by 2 past senior projects and led to the issuing of a patent. This system would allow for seats to be rapidly configured from seated to nested positions by the driver in order to make more floor space. When all the seats are fully nested, the configuration frees up about 64% of the floor space.
Now I will go into a brief overview of our design and explain how our project teams are organized. So this project was split into 3 separate project teams. First was the system team, which is our team, which focused on the integration of all the components of the final design, along with the aesthetics and ergonomics of the seat. Next, we have the articulation team, which focused on the stowing motion of the design. This allows the seat to go from a seated position to a vertical position to save space. And finally, we have the track and latch team, which focused on the nesting movement of the design. This nesting movement allowed the seat to be locked into place and also moved back and forth along the length of the vehicle so that the driver could make the seats go in whichever configurations they needed. To explain these 2 critical motions a little further, we'll first start with the stowing motion. So the stowing motion again allows the seat to be put in a vertical position. First, to unlock the seat, the driver just needs to pull the lever on the back of the seat. This will then allow a gas spring located inside the seat to automatically push the seat up into the vertical position. As you can see in the picture on the bottom left, there's the fully deployed and fully stowed positions. To put the seat back in the fully deployed position, all the driver has to do is push the seat back down until it clicks in place, locking it in the seated position. Now I'll briefly go over the nesting movement of this design. Again, the nesting movement allows the seat to be moved forward and backward along the length of the vehicle. So first, to unlock the seat from its current position, all the driver has to do is push up on the foot pedal, allowing the seat now to slide freely back and forth along the length of the track. Now, when the driver puts the seat in its new location, all the driver has to do to lock the seat in that position is to push down on the foot pedal until it locks back into place. This allows the driver to put the seats in multiple configurations, and these benefits will be explained more on the next slide.
This new design allows drivers to better fit the diverse needs of passengers on the fly. Nesting and stowing the seats allows for more floor space for things like luggage or bikes and provides space to secure wheelchairs, which increases accessibility. This allows companies to have less vehicle types, which is a better use of money and provides a more valuable experience to riders.
Before selecting our final design, we had several initial seat iterations, one of which is shown in the picture on the left. This design was based on a typical Sprinter van seat. However, we changed the vehicle type we were designing for to be a shuttle bus, which has a much different interior as shown in the comparison on the right. We iterated our design to reflect this change by switching to plastic and simplifying the seat so that it is easy to clean, lightweight, and allows the articulation components to be housed inside of it. We converged on our current design to minimize costs while still having a sleek, aesthetic design that doesn't compromise on its ergonomics or comfort.
So as Audrey said, some of our main design goals were user safety and user comfort. These were achieved with our plastic seat housing and our track and latch housing. Both of these go to cover any pinch points and a lot of moving components, which will go towards user safety. The plastic seat housing also has an outer shell that is both aesthetic and ergonomic, with a contoured back and some light cushioning for user comfort. Instead of actually making full-scale prototypes of these, we shifted our focus to writing a grant to the Transportation Research Board, which will go to fund the future design and iterations of this project.
Since we did not have a model to physically test, we instead spoke to the local transit organizations, Slow Transit, and Regional Transit Authority to gain feedback on the design. They recommend the following. First, minimizing weight, which will increase vehicle efficiency and won't limit passenger capacity. Next, they recommended minimizing sharp corners to limit snagging and to incorporate bushings in order to avoid squeaking or rattling. And lastly, and most importantly, to make the seats tamper-proof so that only the drivers can reconfigure the seats. This is most important for public transit applications. These are general system-wide improvements that future teams can focus on. The articulation and track teams will elaborate on their design and testing experiences and their specific recommendations in the following videos.